Good morning. My name is Graysen Vigneux. The poster I will be presenting today will be explaining the radiation-induced functional changes in the lens epithelial cells. It has been said that the lens of the eye is one of the most radiosensitive tissues in the human body. Since it is known that ionizing radiation targets actively dividing cells, the lens epithelial cells are believed to be the main target of radiation because they are the only dividing cells in the lens of the eye. There has been a controversy on how radiation affects the lens. It has been claimed in recent studies that there is no threshold dose for damage to the lens and that any increase in radiation dose is associated with an increased biological complication. Secondly, it has been recently brought to light that there may be no dose rate effect when it comes to the lens of the eye. My research will help clarify these assumptions by examining the mechanisms of radiation exposure in cultured lens epithelial cells, as well as the functional changes and alterations in cell proliferation resulting from the exposure to ionizing radiation. When looking at the data presented in this poster, starting by figure 3, which is comparing acute doses of radiation to fractionated doses, we clearly see an increase in cell survival when doses are delivered in fractions. Secondly, in figure 1, when we are looking at the migration of these cultured cells, we can see that a higher acute radiation exposure leads to a greater number of cells migrated. Lastly, in figure 2, where we are looking at the wound closure rates, we can see that higher acute radiation exposure leads to longer wound closing times. To conclude, my future research will be looking at the adhesion properties of human lens epithelial cells and how it is altered when exposed to ionizing radiation. Thank you.